Hi, this is Suchi and today I am going to talk about how we can create NumPy array. Now, if we look into the documentation, we will be able to see 6 different methods. Here you can see 6 different methods are listed of NumPy array creation. And the first method, which is this one, conversion from other Python structures, for example, list, tuple, etc. So I will be leaving this documentation link in the description. Now, let us look into the first process, which is conversion from other Python structures, example list and tuples. So what does that mean? To create a NumPy array, we are actually using some list or tuple, this kind of Python structure, and we are creating the list. We are creating the NumPy array or ndarray. So let us look into what is the value of n we can support in this method. So n could be 0 dimensional, 1 dimensional, 2 dimensional, n dimensional. So n dimensional means 3, 4, 5 and so on. So 0 dimensional, how we can create a 0 dimensional array? So if we just pass a single element, then it will become a 0 dimensional ND array. Let us look into it. So here you can see we have defined ARR0, which is a variable, and we are going to create a 0 dimensional array with this name. So what we are doing is np.array method we are using, and we are passing a single element. Here you can see I have used one integer element, integer number 37. And if I run this, and here I have added some print statements. So first of all, I am printing the array. Then I am printing the data type of this variable ARR0. Then I am printing the ndim. I am using ndim to print the dimension of the array. Then the data type of the array and shape of the array and size of the array. So all these things we have already learned in our previous session. Now I am just going to run this cell to show you how this 0 dimensional array look like. So I have run this. Now you can see the array is nothing but a single element. And the type is definitely NumPy ndarray. Now dimension, as you can see here, it is a 0. So it is a 0 dimensional array, as I mentioned. And data type is definitely integer, and it has taken from the, it has interpreted from the value as int 32, as we have not mentioned any data type, as we have not specified any data type separately. So it have just interpreted from the value. Now shape, there is no shape because this is a single element. That is why there is no shape. No dimension and no shape. No dimension and no shape. Now size is 1 because this is a single element. So that's what we can see. That's how we can create a 0 dimensional array in NumPy. Now let us look into a 1 dimensional array. So how we can create a 1 dimensional array? Definitely if we pass a single list inside this np.array function, we will get a 1 dimensional array because this is having only 1 dimension. Previously it was not having any dimension, it was a single element, but this is a list of, this is a single dimensional list, so it will be converted into a single dimensional array. And what is that dimension? That dimension is nothing but the length of the array. So definitely we are also checking all these factors: dimension, data type, shape, size. So let me just run this. So if I run this, you can see ARR1 is nothing but a single dimensional ND array. And here you can see the type is definitely numpy.ndarray. Dimension is 1, as you can see here. And data type is again interpreted from the values. So the data type is int 32. Shape. So as this is having a single dimension, so the shape is showing only the number of elements in that dimension. So here we have 1, 2, 3, 4, 4 elements in this dimension, in this length. So shape is showing the number of elements in that dimension. And then the size, definitely size is number of elements, total number of elements. So that is also 4 here. So this is how we can create a one-dimensional array, one-dimensional NumPy array. Now let us look into two-dimensional. So two-dimensional will be again simple. One thing you can look into, at the beginning, how many square brackets are present? That will be equal to the dimension. Here you can see no square brackets are present. So there is no dimension, that is a zero dimensional thing. And here you can see there is one square bracket present at the beginning. So it is a single dimensional array. Now we can look into two dimensional. And here what I have done, I have added a list of lists. That means a list where each element is again a list. So as this is list of lists, that is why it will become two dimensional, because this is one dimension. The first list, the outer list is the length of outer list is the first dimension, and the length of inner lists will be the second dimension. So if I run this, let us look into this, how it looks like. So if I run this, you can see this is in a rows and column structure. So this is kind of a matrix structure where we can see there are 3 rows and 2 columns. So there are 2 dimensions. One is this rows is one dimension and columns is another dimension here. If we consider it kind of a matrix. So this is the array. Again, this is a NumPy ND array, and the dimension is 2. Data type is again interpreted from the values. Number of values, number of elements is 1, 2, 3, 4, 5, 6. So that is 6 here. And the shape. So the shape is what? Shape is number of elements in each dimension. So the first dimension is the rows. So there are 3 rows, 1, 2, 3. That is why the number of elements in first dimension is 3. And number of elements in second dimension, that is this one, columns. So each array again is having 2 elements. So that is why it is showing us 2. So this is how the shape is interpreted. Now, what if, let us look into 3-dimensional array. So 3-dimensional, while in the array, it could be 3, it could be 4, it could be anything. But as I will keep increasing the value of n, this structure will become more complex and it will be less human readable. So definitely we can keep adding. Let us just look into n equal to 3. So here what is happening? This is a list of lists, and again each list is also a list of lists. That means this is a list where we have 3 elements, which are this one, and this one. And each element is again a list of lists. So this is again a list which is having again 3 elements, 1, 2, and 3. And again each element of this list is a list which is having 2 elements. So let us look into this, how this 3-dimensional array is coming up after I run this. So here we can see at the beginning 1, 2, 3. 3 square brackets are there. So definitely this is a 3-dimensional thing. That is why we can see 3 square brackets at the beginning. Now how many elements are there? Definitely 18 elements are there. So the size is 18. Total 18 elements, because 2 rows, 3 columns, 3 into 2, 6, and 6 into 3 is 18. And then what is the dimension? Dimension is definitely 3, as we already looked into it. And now what is the data type? Data type is again interpreted from the values, that is in 32 here, and the shape. So what is the shape? Again, I told you that shape is the count of elements in each dimension. So the first dimension, that is this, the outer array, that is having 3 elements, 1, 2 and 3. So that is why first dimension is having 3 elements. Now the second dimension, which is, let's say, one of these elements. So if this is one element, how many elements are there in this array? 1, 2, 3. So the second dimension is again having 3. Now each of these elements, if we look into, let's say we look into this one. So how many elements this is having? 1 and 2. That is why the third value of this shape is 2. So this is how we can determine the shape. So this is all about the 3D NumPy array. Now let us look into 4D NumPy array. So same thing, what we are doing, this is list of lists. Again, this is a list of elements which are list of lists. And then again we are adding 2 such elements into another list. So it becomes a 4-dimensional array. And if I just run this, you can see here at the beginning 1, 2, 3, 4, 4 square brackets are there, 4 starting square brackets are there. So this is 4D array. And if I look into the dimension here, you can see this is 4. What is the data type? Again, data type is int32, that is interpreted from the values. And let us look into the size. So size is number of elements. So number of elements here, if we look into this individual elements, there are 2 into 3, 6 elements. And 6 into 2 is 12. And we have 4 such arrays here. So 12 into 4. That is why we are having total 48 elements. So this is the size of the ND array. Now what is about the shape? So as we were looking into, shape is nothing but the count of elements in each dimension. So how we can determine the shape here? So in this dimension, in this particular array, the outer array, how many elements are there? 1 and 2. So there are 2 elements. So first dimension is having 2 elements. Here you can see 2. Now the second dimension. Second dimension is what? Second dimension is this one. So let us look into this. How many elements are present for this one? So here you can see, if we just give the correct spacing. So how many elements are present? 1, 2, 3 and 4. So here you can see 4 is there. Now individual elements of this dimension, let us look into this one. So if we look into this one, how many elements are there? 1, 2 and 3. So there are 3 elements in the third dimension. So here we can see there are 3 elements in the third dimension. Now comes the fourth dimension, which is this one. So individual elements of this particular array is 25 and 37. So 2 elements are there. That is why in the fourth dimension we have 2. So this is the shape 2, 4, 3. So I guess you have got an idea how we will determine the shape, how we will determine the dimension of the ND array. And this is the way how we can have even higher dimension arrays with the help of list, or even we can use tuple over here, and we can just use the np.array and pass that element, pass that list or tuple, and that will get converted into a NumPy array. So that's it for today. We will look into other methods in our next session. Goodbye. Till then, keep learning, keep implementing. Thank you for watching.